In this video, I want to talk about an example using pointers that's similar to one that you see in the homework. So we're going to start with making an integer, int I, and I'm going to assign it the number 7. So somewhere in our stack of memory, the compiler said, I'm going to go grab 4 bytes, and I'm going to stick the 32-bit value 7 among those 4 bytes. Now I'm going to define a pointer. I'm going to call it KP, and I put the star in front of it to say, hey, I'm not just making an integer here, I'm making a pointer to something of type integer, and I'm going to say it gets the address of I. So KP now knows where I is, and if I asked for star KP, it should give me the number 7. So now I'll make another variable int j, and I'll say that j is equal to star KP. Okay, so what does that mean? That means that j, if we'd asked for j, is equal to 7 at this moment. Now I can change the value of I. I could say I, and maybe I'll change it to a hexadecimal number, AE. Okay, so now I has that new value in it. J is still 7 because we haven't told j to change, even though j is pointing to the value of I, but it hasn't been told to update yet. Now I'll make another pointer. I'll say int star np is equal to the, we'll give it the value kp. Okay, so the value kp is the address of I, so now np is also pointing at I. Okay, I can say star np is equal to hexadecimal 12. Okay, so np points to I, so star of I says change the value of I to 12. So I was initially 7, we changed it to AE, now we changed it to the hexadecimal 12. And I could say j equals, give me the value of kp. Okay, kp also points to I. This line changed I to 12, so this essentially said that j is now hexadecimal 12. So this kind of math, this is really just an example. We don't really see that in code very often, but it helps you wrap your head around what is a variable, what is a pointer to the variable, and how can I assign things using a pointer, or how can I grab the address if I only have the name of the variable. Okay, let's talk about arrays, because arrays are essentially a good understanding of how pointers work. So I can make an array of integers called int a, and maybe I want 10 of them. Okay, think about your stack of memory inside of the computer. Started at address 0, and it went up to whatever the maximum amount of memory we have is. The compiler is now going to say, okay, I'm going to go grab a chunk of memory. It doesn't necessarily start at the bottom. It just does whatever it does inside of itself to pick the first address. So here's the first set of 4 bytes because we have an int. So that this block is going to represent the first byte. So what is the first byte? The first int inside of A0, A10. So how do we refer to the first element inside of this array? The first element is A of 0. So this value inside of here is A of 0, and then the next one would be the value A of 1, and the next one would be the value A of 2, and so on. And what would be the very last one? The very last one would be A of 9. So from 0 to 9, we have 10 values. So we never actually refer to A of 10. So this keeps going. What is the address of A of 0? So we could say the address of A of 0 is ampersand A of 0, because A of 0 is the first value within this array, and ampersand of it gives us the address. Now, the cool thing about an array is that ampersand A of 0 is the same thing as just saying A. So when we refer to the name of an array, it is the pointer to the first byte of the first element of that array. An even cooler thing is, what if I said, what is A plus 1? So a plus 1 is the pointer to a of 1. So this is the same thing as saying, give me the address of a of 1. That's a little confusing because a is an integer. So we know that if we take the address of the first byte of a, when we add 1 to it, we think, whoa, we're just going to get the second byte within that integer. But instead, the pointer knows two things. It knows both the address of the byte that it's pointing to, and it knows the type. So because it knows it's a type integer, it knows that, oh, if you add 1 to the address, you probably don't mean go to the next actual byte. You mean go to the next integer within this array. So a plus 1 means the physical address it's going to add 4 to get to the next value within the array. So that's pretty cool. And the main takeaway is that pointers know two things. They know the address and they know the type. And an array, the name of the array, is the pointer to the first element of that